So look at this question. The question is correct the statements if required. Okay. So the first part A is what? 1 mole of chlorine contains 6.023 into 10 is for 10 atoms of chlorine. Okay. So the first thing is that you have what? 1 mole. You have what? 1 mole of chlorine. Okay. So we are doing what? A part, you have what? 1 mole of chlorine. Okay. Now what does it mean chlorine? Whenever in a question these type of statements are there, like 1 mole of chlorine or 1 mole of oxygen or 1 mole of hydrogen or 1 mole of nitrogen, like this. Okay. So in that case what you have to take? You have to take Cl2. Okay. Because even in day-to-day life, if suppose if I'm saying that oxygen are there, okay, in this room oxygen and nitrogen are there, okay, so that means oxygen are there, that means the molecules of oxygen are there, okay, in the atmosphere, not in this O, okay, or the molecules of nitrogen are there, okay. So if you're saying that chlorine, okay, so that means what is it? It is Cl2, okay. And if 1 mole of chlorine, that is Cl2, that means what? 6.022 into 10 h power 23 molecules of chlorine, molecules of chlorine. And as we can see by the formula, that is molecular formula of chlorine, it is what? Cl2. That means 1 molecule of chlorine contains 2 atoms. 1 molecule of chlorine contains 2 atoms of what? Chlorine. So this is what? 2 into, we can say, that is 6.02 into 10 to the power 23 molecules of chlorine will contain what? 2 into 6.022 into 10 to the power 23 atoms of chlorine, atoms of chlorine. So this particular point is again important, that you have to take chlorine. If it is written only chlorine, that means basically it is what? Cl2. If it is only oxygen, it is what? O2. If it is only nitrogen, it is what? N2. Okay. If it is N, they have to give the question like nitrogen atom. Okay. Okay, they have to give this like what? Nitrogen atom. Okay. Okay, got the point. So I think your first part is over. Okay, now come to the second part. What is that? Under similar conditions of temperature and pressure, 2 volumes of hydrogen combined, 2 volume. Okay, so first let's see, this hydrogen is there. Okay, as I said, hydrogen means what? It is what? H2, not H. Okay, so it is what? H2, because it is only hydrogen. Okay, combined with 2 volumes of again oxygen. Okay, so again you are what here? You are here with what? O2. Okay, and that is giving you what? Water vapor. Okay, so that is what? H2O. So basically this is a question of what? Stoichiometry. And when we are dealing with the question of stoichiometry, first you have to write the chemical reaction and then you have to balance it. Okay, the first and foremost thing what you have to do when you are dealing with a question of stoichiometry, you have to write the chemical reaction and then you have to balance it. Okay, so first balance, we have already written this chemical reaction. First, now what to do? You have to balance this chemical reaction. So how to balance it? Simple. This is what your 2H2 and this is what your 2H2. Okay, and if nothing is written here, that means what? It is what? 1 1. Okay, so now these values are what? These values are what? Your stoichiometric coefficient. These values are what? These values are what? Stoichiometric coefficient. Okay, stoichiometric coefficient. Okay, these values are stoichiometric coefficient. That means these numbers before reactant or before product in a balanced chemical reaction. That is important, in a balanced chemical reaction. So these numbers are what? Stoichiometric coefficient. Now look at this. Under similar condition of temperature and pressure, these stoichiometric numbers give you information what? That is, it is what? 2 liter or 2 volume, you can say 2 volume, whatever the unit of volume, 2 volume of hydrogen is reacting, 2 volume of hydrogen is reacting with what? One volume of oxygen, 1 volume of oxygen, and giving you what? 2 volume of what? Water vapor, 2 volume of water vapor. So what should be the correction here? 2 volume of hydrogen, perfect, fine, combines with 2 volume, no, it is what? 1 volume of oxygen, and will give what? 2 volume of water vapor. So hope you understand this part. Now come to the third part, that is your C part. Okay, so the see this particular question, relative atomic mass. Okay, whatever the mass you calculate in terms of U, that is your unified mass, atomic mass. Suppose if we call that atomic mass of sodium, atomic mass of sodium is what, 23U. It means what? It means first thing that you should keep in your mind, that this is a relative mass. This is a what? Relative mass. And relative to what? Okay, so it is relative to 1/12 of the 1/12 of the mass of an atom of C12 isotope. 1/12 of the mass of an atom of what? C12 isotope. Mass of an atom of C12 isotope. Okay, so basically what this is what your relative value. That means just take the mass of an atom of C12 isotope, uh, divide it by 12, and then whatever the value it comes, okay, from that value the one atom of this sodium is what, 23 times heavier than that value. Okay, 23 times heavier than that value. So this particular atomic mass of sodium is what, your relative atomic mass. That is the meaning of relative atomic mass. That means if you want to find the exact mass of this sodium, what you have to do, you have to just multiply with this value, that is 23 into what, 1.66 into 10 h power what, minus 24 gram. Just I'm giving you one example. Suppose if your mass is suppose 100 kg, okay, okay, and if it is, reduce your mass, okay. So if your mass is 100 kg and suppose, okay, my mass is what, 20 kg, okay, so what I am basically, you are 5 times heavier. You are what, 5 times heavier than me. All right, what does it mean? That means your relative mass is 5 with respect to me. Okay, so if you want to find the exact mass, what you have to do, you have to multiply this 5 with this 20. Okay, so again I'm doing the same thing. This one sodium atom is what, 23 times heavier than 1/12 of the mass of an atom of C12 isotope, and that value is what, 1.66 into 10 h power minus 24 grams. So if you want to find the exact mass of sodium, what you have to do, that is 23 into 1.66 into 10 h power minus 24 gram. Okay, so now I think this relative atomic mass, the concept of this relative atomic mass is what, clear? Is the number of times one molecule of element is heavier than 1/12 of the mass of an atom of C12 isotope. Okay, so it is not molecule, basically what, one atom, because we are talking about what, relative atomic mass. We are talking about what, relative atomic mass. So what should be the correction here? Instead of molecule, it should be what, atom. Okay, or maybe you can correct here also, relative, keep this molecule there. I mean, you can correct here also, keep it molecule intact with this particular statement, just change this atom. Okay, this changes the atom by molecule. So there are two corrections possible here. You can change atom by molecule and leave this molecule as it is, or you can keep this relative atomic mass as it is and you can change molecule by atom. So hope you understand this concept. And now moving to the fourth question. Now look at this D part. Under the same conditions of the temperature and pressure, equal volumes of all gases contain the same number of atoms. Okay, so now see, just suppose in an example, okay, this is what the statement of Avogadro's law, that equal volume of all gases, okay, if equal volume of all gases contains same number of moles of that gas. Okay, equal volume of gases contains same number of moles if your pressure and temperature is what, constant. Okay, so is it equals to the, again, the contains the same number of atoms? So now, I mean, look at this. I'm just giving you one example. Suppose you have equal volume of oxygen, and if you have equal volume of O3, that is your ozone. Both are what, gases. Okay, oxygen and ozone. So if you have equal volume of oxygen, if you have equal volume of oxygen and ozone, that means the number of moles of both will be what, same. So let's suppose it is what, x moles. So we have what, if it is equal volume of both gases, we have what, x moles of O2, and we have what, x moles of what, O3. Now if it is x mole, that means what, x into Avogadro number, that is what, Na molecules of O2, x into Na molecules of what, O2, and here it is what, x into Na molecules of what, O3. But when you will calculate the number of atoms, Here the number of atoms will be what? One molecule contains what? Two atoms. So this much molecule will contain what? 2 into X into Na atoms of what? Atoms of what? O. Okay, atoms of O. And if you're calculating this particular value, that means in this case, if one molecule contains 3 atoms, so that means this much molecule will contain what? 3 into X into Na atoms of what? O. Okay, so in both the case you can see the number of atoms are not same. Okay, number of atoms are not same, but the number of molecules are same, as well as number of moles are same. Okay, so that means what you can do, you can replace this atom by mole, or you can replace this atom by what? Molecule. Both are correct. So I think, hope you understand this concept. Okay.